Hey, Honors Chem students, Mr. Lambert here. Hope you had a great weekend. This is a quick video on section 8.1. We are starting lesson 8, chapter 8, pages 225 to 228 will be covered in this lesson. Again, section 8.1. It covers the basics of chemical equations. So I've turned my screen. Here is my board. And again, section 8.1 talks about equations for chemical reactions. What I have written here is a chemical equation. Just want to go over the basics. We've talked about it in class, but that was a long time ago. Basically, a chemical equation does not use an equal sign. It uses an arrow because chemistry is all about uh, objects, substances, combining to make new things. So what we have here on the left-hand side, we call the reactants. This chemical here is a reactant. This chemical here is also a reactant. We have hydrogen gas here, as well as oxygen gas. I'll talk about these states of matter in just a second. Then we have a yield arrow, what the reactants are producing. What the reactants combine to form are called the products. In this particular equation, there's only one product that is being formed. Most of you recognize it. It's water, but it's water vapor. It's written as H2O as a gas. Let's see. So often after you see the particular chemicals involved, you see the states of matter. It lets you know what particular state they're in. In this particular case, we have hydrogen, H2, and it's written as a gas. Oxygen is also written as a gas. And water, in this particular case, is also a gas. Down below here, I've written what you'll commonly see accompanied after each particular chemical. S, of course, is solid. L, I read it as sort of a cursive L, so you know it's not a 1 or something like that. Liquid, G is gas, and AQ means aqueous. It is dissolved in water. So section 8.1 basically wants you to understand the concept, the basics behind a chemical equation and how they're written. Sometimes, let me get my marker. Sometimes chemical equations can be reversible, and we use a double arrow going back to the left-hand side, but we're not worried about that right now. That's more when we talk about equilibrium. So right now, just make sure you understand reactants on the left-hand side, then a yield arrow, product, or sometimes there's more than one product, products on the right-hand side. And section 8.1 wants to make sure you can identify whether an equation, a chemical equation, is balanced. So we have to discuss the law of conservation of matter, which states that matter in a regular chemical equation, matter can neither be created nor destroyed. So when you look at the different chemicals involved, we need to be counting total atoms. So basically whatever we have on the left-hand side, we have to have on the right-hand side. And for section 8.1, it just wants you to be able to identify if an equation is balanced or not. This equation is on page, I believe, 226. I apologize, it's on page 227. 2H2 plus O2 yields 2H2O. Let's take a look and see what we have for each element. For hydrogen, notice that right now we have H2. That's how hydrogen gas is written. But there's a big 2 in front of it. There's a coefficient, which means we have 2 molecules of hydrogen gas. We have 2 H2s. It's like writing H2 twice. So if this is how hydrogen gas exists, and we have 2 molecules of it, think about the distributive property in math class. 2 times 2 gives us a total of 4 hydrogens. We have 4 hydrogens on the entire left side, on the reactant side. Do we have the same number of hydrogens on the right-hand side, on the product side? Let's go over here to our single product, our water. If you look, there's a big coefficient 2 in front of the water. This is telling us we've produced 2 water molecules. If each water molecule is H2O and we have 2 of them, then we have a total of 4 hydrogens. So 4 hydrogens on the left, 4 hydrogens on the right. It's good to go. The only other element we have to think about is oxygen. What do we have on the reactant side? Looks like with this particular molecule, oxygen gas, which is what we're breathing in, there are 2 atoms for every 1 molecule. Notice there's no 1 here, it's just the molecule written. There are 2 atoms total in this molecule. If you look on the right-hand side for oxygen, we're not even worried about hydrogen right now, we're looking at oxygen. If you distribute this coefficient of 2 for these water molecules, notice I drew these 2 water molecules here. Each water molecule has 1 oxygen, but there are 2 of them for a total of 2 oxygens. So quick recap, 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, 2 times 1, 2 oxygens on the right. This particular equation is balanced, and that's what they want you to identify in section 8.1. Okay, last part of this section 8.1. I have listed problem 8.4D on page 228. This first section wants you to be able to identify if a chemical equation is balanced or not. Let's do this really quickly. We have solid magnesium. We know that it's solid and it's Mg. Solid magnesium is going to react with the other reactant, in this case, nitrogen gas. There's our yield arrow. Here's the product side. It's going to create something called magnesium nitride. And again, it's in solid form. Is this equation balanced? Let's look at each element and make sure it obeys, they all obey the law of conservation of matter. Magnesium, I see 1 here, no coefficient, no subscript, 1 magnesium on the left, on the reactant side. There are 3 on the right. There's no way that this is balanced. We're going to have to put some coefficients in front to balance that, but that's next section. Nitrogen is actually balanced as this equation stands, as it is. So it's the magnesium that we need to figure out. And even though I said that we're not going to balance it right now, and that's the next section, what we would do is we would put, because there's a subscript 3 right here on the product side, we can't put a subscript 3 here. Magnesium does not exist by itself as magnesium 3. What we can describe, however, is 3 single magnesium atoms. So what we would do is we would put a coefficient of 3 in front of that. And that's what section 8.2 is going to be all about. I'm going to pause it so I can write that 3. Hey, the 3 magically appeared. Now we have a balanced chemical equation.